In this video, I'm going to walk you through creating models, writing queries, and writing statements to add, delete, and update code in a database using Flask-SQLAlchemy-Lite. So the reason why I'm using Flask-SQLAlchemy-Lite is because I believe it works better than Flask-SQLAlchemy with the newest version of SQL Alchemy, which is 2.0. So before 2.0, regular Flask-SQLAlchemy was fine, but with version 2.0 of SQL Alchemy, I don't think Flask-SQLAlchemy is a good library to use anymore. So to replace it, I will use Flask-SQLAlchemy-Lite. You'll see in this video, Flask-SQLAlchemy-Lite is a very thin layer over SQL Alchemy. So there's really nothing to learn about the extension itself. Most of what I'm going to cover in this video has to do with SQL Alchemy itself, and there's only minor things where Flask-SQLAlchemy comes into play. So if you're interested in learning all that, just watch this video. It's a longer full tutorial, but I hope you get some value out of it for your Flask projects. Okay, so to get started, I have an empty project here. So the first thing I want to do is UV init. So this will just create everything I need to install things. I'm going to use a file called app.py instead of main.py. So I'll just change the name of the file. And now what I want to do is I want to install the two main things that I need for this video. So first I want to install Flask, of course. So I'll do uv add Flask. And then I'll also do uv add Flask-SQLAlchemy-Lite. And the reason why I'm using Flask-SQLAlchemy-Lite is because I don't like the features of Flask-SQLAlchemy when they relate to the newest version of SQL Alchemy. So the whole reason why I'm making this video is because I want to show you how to work with SQL Alchemy 2.0 in Flask. And Flask-SQLAlchemy-Lite is the better library for doing that, in my opinion. So I just installed both things. So let's go over to app.py. And I'm going to keep everything in app.py for this video. Of course, in a real app, you'd separate things out. So I'll start by importing Flask. So from Flask, import Flask. Then I also want to import Flask-SQLAlchemy-Lite. And I want to import the SQL Alchemy class from Flask-SQLAlchemy-Lite. So this is very similar to how regular Flask-SQLAlchemy works. And then I'm going to create an app object. So app equals Flask under name. And then I'll set up some configuration here. So app config, and then I need to config SQL Alchemy engines. And in there, I'll have the default database that I'm working with. And then that will be my SQLite database that will be auto-generated for me. So I'll do SQLite : / and then db.SQLite3. So that will add that to my Flask app onto the config. And now I want to instantiate the database object. So I can do db equals SQL Alchemy. And then after that, db.init app, and just pass in the app. So let me just put a space here. And that is enough for the setup. So now that I have the basics set up, the first thing I want to do is I want to create my first model. So the model is a code version of what will eventually be the database table. So in SQL Alchemy, each table that you want to create, you create a class. That's the basics of using the ORM in SQL Alchemy. So before I can do that, I need to import something called the declarative base. So this is going to come from SQLAlchemy.orm, and I want to import the declarative base, and I just spelled that wrong. And then down here, I'm going to add a class called base, which is just going to inherit from the declarative base. So declarative base like that, but I'm not going to make any changes to this class. So the idea is I'm making this class here just in case I want to add some extra things to the declarative base. In this case, I'll just use the default, but it's a lot easier to create this now. So if you need to change it in the future, you can. So I've added that class. And the idea is every class that represents a table, so every model, will need to import from this base class. And the main purpose is to group all of our models together to have them be recognized as SQL Alchemy classes. So if we didn't use the base class for all of the models, then our class would just be a regular Python class. So in this video, I'm going to create like three main models. So customers, product, and order. And to create each one, I'll just create a class. So class customer, and then it's going to inherit from base. And I'll just do pass for now. I'll fill in everything later. There's going to be customer order. So the reason why I have this is because each customer can have multiple orders. And then I'm going to have a product model base. So for the customer order class, I could have called this order because it does represent orders, but order is a reserved word in SQL. So I think just to avoid any confusion, I'm just naming this customer order instead of order. Because like if you have an order by in your query, then it's going to use the word order. So by naming this customer order, there won't be any name collisions. So now that I have the three classes, every single class needs a table name. So to do that, inside of the class, I can remove this pass now. You do dunder table name, and then the name of the table as a string. So for example, customer here, and then I can do the same thing for the other two. So this one won't be customer, but it will be customer order. And this one will be product, right? So if you've used Flask-SQL-Alchemy, you've probably haven't had to do these things here, the table names, because Flask-SQL-Alchemy did it for you automatically, whereas Flask-SQL-Alchemy-Lite won't do it for you. You have to do everything yourself. And like I said, this works better in the new version of SQL Alchemy. In the old version of SQL Alchemy, I recommend using Flask-SQL-Alchemy. But for this newer version, I definitely think you should take this approach. But adding one extra line to the class is not that big of a deal. So now that we have the names for all the tables, we want to start adding some columns to these tables or attributes to the classes. So up here, what I want to do is I want to import a couple more things. I'm going to import the mapped class, and I'm going to import the mapped column function. And then I can go down to, let's do product first, because that one's pretty simple. So I want to add all of the columns that I want. So there's always going to be an ID column. So I'll just add that there. I'll add a name column and I'll add a price column. Okay. So the way that you set this up in the new version of SQL Alchemy is by using type hints. So I'll do ID colon and then the type hint. So the type hint in SQL Alchemy starts with the mapped class. And then inside of the square brackets, you put the type of the column. So in this case, this is going to be an integer for the ID. For name, same idea, but instead of an integer, it's going to be a string. And for price, I'll make that an integer to keep it simple. And then in addition to passing the type for the column, I can also pass in extra information, and that's where the mapped column function comes into play. So mapped column, and then inside of here, the ID is going to be the primary key. So I can just say primary key equals true. For the name, I can say how many characters the name can be. So I can say string 50, and I just need to import this string, which comes from SQL Alchemy. So from SQL Alchemy, import string. And then also when I go down to name, I can also say that this is going to be unique. So I can say unique equals true, meaning if there is a name used more than once, the database will throw an error. Okay, and then for the price, what I can do is just leave it as is. So I don't have to pass in anything for map column. I can just say price, and then it's going to be an integer. And the main thing that you need to know here is by default, these columns are not null, meaning that when you insert data into the database, you have to pass in a value for all of these. So even for the price, even though I don't have map column, it will throw an error if I try to insert a record without a price. So just keep in mind that the default is not null. And we'll see that later when it comes to inserting. But for now, this is what we have. And then for customer, I'll do the same thing, but I'll just paste it in because it's the same idea. And I'll just talk about what happens here. All right. And then for customer, we'll move on to here. And I already have the fields. So what I'll do is I'll just paste them in and I'll just discuss them because they're so simple. So for the customer, I want first name, last name, address, city, postcode, and email. As you can see, they're all strings and there should be one ID. So I'll just take the ID from the product and I'll put that there. Let me add a space here. That looks a little bit better. So we have the ID here, primary key equals true, but everything else should be a string. So some are 50 characters, some can hold up to 500 characters, and they're all going to be not null because that's the default. And then for email, I'm just saying that each email needs to be unique when it is inside of the customer table. So now let's go over to customer order. And what I want to do is I'll type out these because some of these are going to be different. So for the ID, I'll paste it in because the ID is going to be the exact same, but I'm going to have an order date. I'm going to have a ship date. I'm going to have a delivered date, and I'm going to have a coupon code. Okay. So for coupon code, it should be pretty obvious that this is going to be a string. But the thing is, for every order that is placed in my system, I don't want to require that the user has a coupon code. So how do I make this not null? So how do I make this a nullable field or an optional field? Well, to do that, I can import from typing. So from typing, import the optional class. And then I can wrap the type with optional. So here it is. I will do mapped and then optional and then the data type, which will be a string, right? So this will make the coupon code optional, whereas these other fields are going to be required. And then for this, I want to specify the number of characters that can be in a code, let's say up to 10 characters. So for the order date, ship date, and delivered date, they're all going to be dates. So for this, I want to use date time. So what I'll do is I'll import from datetime, import datetime, and then also time zone, because I'll use that for something in a second. I'll show you that. And here on the order date is always going to be required because there's no point in creating a customer order record without an order date. So for this, I'm going to say mapped, and then the type is going to be datetime, which I just imported. And then for the order date, I want to have a default date, meaning as soon as you create the record, we're going to mark that as the order date. So I can do map column here, and then I can specify a default. And that default will be datetime.now. And I want this to be stored in UTC. So I'll do timezone.utc. So that's why I imported time zone. And then for ship date and delivered date, those are optional because the ship date happens sometime after the order, and likewise the delivered date. So what I'll do is I'll make them both optional. So optional, and then their date times. And I can just copy and paste because this one will be the same. So that's it for the basic columns. This represents all the basic columns that will be in the database. So before we actually create these in the database, we want to focus on foreign keys. So first, let me start by importing foreign key from SQL Alchemy. So foreign key. And the reason why we want foreign keys is because we need a way to relate these customer orders to customers. And likewise, we need a way to relate the products that are in an order. So let's start with customer orders. So the first thing we want to do is we want to add a field called customer ID. So that means that this order belongs to a particular customer. So this will be an integer column. So mapped int, and then I'll call mapped column. And for this, I'll pass in foreign key, if I can spell it correctly, foreign key. And then customer.id will be where it's pointing to. So it's pointing to the customer table and then the ID column. And then what I want to do is I want to set up the ORM connection between customer order and customer. So on the customer order, I can have an attribute called customer. And this is going to be mapped and then list customer. So the type is going to be a customer. It's going to be a list of customers. For this particular one, it's only going to be one customer per order, but I can still use list here, depending on the type of relationship. And then I want to do relationship here, which I'll need to import, and then back populates, and then customer order. So what this means is it's going to be looking for an attribute called customer order on the customer table, because that's where the class is here. And then it will make the connection. So let me do the other side here. So customer order, and then mapped list and customer order, just like that. And this is also going to be a relationship. And it's going to have back populates customer, right? So these back populates come in pairs. So this customer order one points to customer here, and this customer one points to customer order. So they always come in pairs. And now let me import everything. So from typing, we need list, and then from the ORM, we need relationship. And that should be it for the connection between orders and customers. Now we want to worry about the connection between customer orders and products. So to do that, I'm going to bring in something called table from SQL Alchemy, because we're going to create a table, but this won't be an ORM table. So table, and then this is also going to have column, and then we already have foreign key. So I'll go down here, and let's say after the customer table, seems like a decent spot, we can create our new table. So customer order product. So that's going to be the name of our table. And it's going to take in table. And then we'll call this customer order product table. It needs to take in the metadata. So base.metadata, that comes from the base class that we have here, which inherits from declarative base. So that's the second argument. And then I need to define some columns. So I pass in column here, and then one will be the customer order ID, and the other will be the product ID, right? So this is creating basically a many-to-many connection between orders and products. So after the customer order ID, I'll use foreign key here, and then this will point to customer order.id, and I'll do the same thing for the other one. So this will be a foreign key, but it's going to point to the product table. And then they're both going to be primary keys. So they both are primary keys together. So primary key equals true and true here, right? So this is another way of defining a table. And the reason why you want to define a table like this is when you don't need to modify it directly. Like you want it to be modified automatically when you use the other classes, but you still need to define it. So this table is not one you'll manipulate directly, but as you create orders and put products on them, the data in this table will change according to the schema that you have here. So now that I have this, let me set up the relationships. So let's start with product. And on product, we want to get all the customer orders for a given product. So I can say customer orders, and then this is going to be mapped list. And then this points to the customer order table. And then we'll do relationship. And for the relationship, this is a little bit different because it's not a direct relationship to customer order. We have to go through the customer order product table. So I can say secondary first. So secondary will be the table that it goes through, and that's going to be the customer order product table. And then I can have the back populate. So back populates is going to be products. And then I can do the same thing on this one. So it's back populating products. So I'll put products here. And then we'll have mapped list, and then we'll have product here. It's a connection to the product model. And then relationship, the secondary is going to be the same. So this customer order product table. And this is going to back populate the customer orders attribute here. So like I said, these come in pairs. So there's one on customer order and there's one on product. So this should be it. I know I typed out a lot of code before running anything. So I'm going to run this next and make sure it works. And I'm sure I messed up somewhere. So let's go ahead and see what happens when we try to run this. So the first thing I'll do is I'll go down to my terminal and I'll just use the Flask shell. So since I'm using UV, I'll do UV run and then Flask shell. And then we see I already have an issue here. So line 34, I'm missing a comma. So let me go ahead and add that. So line 34, and yeah, I should have a comma after the first column. So let me go ahead and try to run the shell again. And it looks like the shell was able to start. So let's see, I have this instance directory. That's where the database is eventually going to go. So I need to create it first. So what I can do is I can import the base class here. So I'll say from app import base, and then I want to run base. So the name of the class base.metadata, if I can spell that right, .metadata.create_all, and I need to pass in the database engine. So that would be db.engine. So I believe db should already be loaded in the shell. And if I hit enter, that should create the database. So I don't see any other errors. So let me go ahead and exit, and then I'll go into my database. So SQLite 3 and then db.SQLite 3. And let's look at the tables. So we have 4 tables here. We have 3 tables based off of our models. And then we have a 4th table based off this table that we created here. So customer order product, and product. If I type .schema, then I will be able to see all of the columns and everything added. So as an example here under customer, we see all of these are not null. For email, we see it has a unique constraint on it. For customer order, we see that order date, customer ID are not null, but ship date, deliver date, and coupon code are all nullable, meaning they don't have that not null there. And the rest of it, we have foreign keys. So we say the customer ID references the customer table in the ID column. Here, this has a couple of foreign keys. And then I believe there's one more foreign key. No, that's actually it. So just those foreign keys, and that's it. So it looks like the schema that was created in our SQLite database matches the models that we defined here and the single table. So this is the first thing you need to do in your project when you're setting up the connection between your app and the database. You need to define all the models that you have. But once you have that, that's most of the code that you have to write until you get into writing the queries that you want. So now that we have the schema set up, let's move on to actually putting data in the database and then eventually reading it. So the first thing I want to do is I want to add some data into the database. So what I'm going to do is I'm going to use the Flask shell to do this. So I'll do UV run and then Flask shell down here. And that will start up the Flask shell. And then what I want to do is import the models that I've defined already. So product, customer order, and customer. And I misspelled customer order. Well, I put a capital R in there. So now it should be fine. Okay, so I have those three things imported. And now I want to add some data. So the way to add a row into the database is by first instantiating one of your models to create an object. So what I want to do is I want to create an object called John Doe. And John Doe will be a customer. So I'm going to use the customer model. And then I need to pass in the fields for customer. So for customer, we have first name, last name. So first name is going to be John. Last name is going to be Doe. And then the address for John, let's say 123 Fake Street. The city is, let's say Fake City. The postcode. So the postcode is also a string. Let's do 12345. And then the email will be John Doe, and I need to put email here first. It will be John Doe at, let's say, yahoo.com. So I'll finish out that string and close the paren on customer. So that will instantiate a John Doe object. So here, when I type John Doe, it says app.customer object and then the memory location. So this isn't in the database yet, but this is the first step. So the next step is I need to add it to the session. So I'll use the DB object, which is imported automatically into the shell. So db.session.add, and then I'll pass that object to add. Hit enter. And now this has basically staged John Doe for insertion into the database. But the record won't actually be inserted until you call commit. So db.session.commit, and this will then save John Doe's record into the database. So let me go ahead and exit the shell here. And then let me open up SQLite. So db.SQLite3. And if I do select star from customer, I should see John Doe. So here we see John Doe. It has all the information that I added. And it also has an ID 1 because that's automatically generated because it's the primary key. So if I add another record, it's going to get ID number 2. I don't have to add that myself. So let me go back to the Flask shell, and I'll just import those things again. I need to use UV here. So UV run Flask shell, and I'll import those things again. So from app import customer, customer order, and product. Okay, so I have those threes imported. And now let me create, let's say, a product. So I'm not going to worry about customer orders quite yet. Let me just create a product or two. So the first product I'll create is going to be a computer. So I've created the variable for the object computer, and then I'm going to instantiate the product class. And then for a product, there are two things I need. I need a name and I need a price. So name, for this, I'll just put computer, and then the price needs to be an integer. And for this, I'll put $1,200. So this represents dollars, so $1,200 for a computer. And then I also want to create another product. Let's call this a phone. So this will instantiate product. The name will be phone. And then the price for this will be, let's say, $500. So I'll hit enter there and instantiate the product as phone. And now I want to add these to the session. So I can do db.session.add phone. And db.session.add computer. And then to save them, db.session.commit. Okay, so I have two products in the database, and I can add an order, so let's go ahead and add a simple order. So we saw John's ID was ID number 1. So we'll use his ID as the customer ID because he's the only customer in my database. So I'll create a first order. So I'll just call this order 1, and I need to instantiate the customer order table. And for this, let's see. So customer ID is going to be 1. That's John's ID. Order date, I'm not going to put anything here because it has a default on it. Ship date and deliver date, I'm not going to add anything on them because I'm just creating the order. I'm not shipping or delivering it, and those are optional. So I want to add the last thing, the coupon code. So I'll say free shipping is the code. And then finally, I want to add all the products associated with this order. So because I have this attribute products here, I can add them directly to customer order when I'm instantiating it. So products equals, and this will be a list, and I need to pass in a list of products. So I already have 2 products here, computer and phone. So I'll close that out. And then I'll add this to the session. So db.session.add order 1 and db.session commit. And now let's go back to SQLite. And let me select star from product first. So we see product now has 2 rows, phone and a computer, and it has the data that I inserted. And then from order, I can do select star from customer order, and we see the 1 order. So here, the ID for the order is 1. The customer ID is 1. This is the order date, 5 a.m. here. And then we get free shipping as the coupon code. And then if you want to see the other table, so the name of the other table is customer order product. So customer order product here. We have the first column represents the customer order ID. So the ID from the order table. And then the second column represents the product IDs in an order. So the first row here is order ID 1 has product ID 2. And order ID 1 also has product ID number 1, meaning order ID 1 has 2 different products associated with the order. So that's great. We see everything's in the database. So now instead of querying inside of SQLite directly, I want to be able to do this in Python code. So let me go back to the Flask shell, and I'll start with customer. So I'll do from app import customer, and from SQLAlchemy import select. So I need to use this select to query. So what I like to do is I like to create the query statement first. So I'll create the variable called statement, and then I'll use select, and I need to pass customer to select, saying that I want to query the customer model. And then one thing I can do is I can add a filter, so a where. So I can do select customer, and then after that dot where, and I can say where the customer ID equals 1, meaning we want the John Doe record. So I'll hit enter, so statement should be saved. And there are various ways I can do this, but one easy way is db.session.scalars and then statement, and then .all at the end. So scalars will just convert it to a usable version basically, and then .all will get all the results for that statement when it queries the database. So I'm only expecting 1, so I'll hit enter, and we see we get 1 customer object when it gets returned. And if you want to have more descriptive displays here in the terminal, I can go up here. I can define a repr method. So repr is like that, __repr. It's going to take in self, and then I want to return an f string. So the first part will be self.firstname space, and then self.lastname. Okay. So now if I go back into the shell, I'll import customer again. So from app import customer, and from SQLAlchemy import select, and I'll create the statement again. So statement equals select customer.where customer.id equals 1, and then db.session.scalars, pass in the statement, and then do .all. So now when I do this, we see John Doe here in the list instead of the customer object and then some memory address. So db.session.scalars is one way to get the results. Another way is db.session.executes, and then pass in statement, and then do .scalars, and then .all. So this will give you the same thing. An even shorter way of doing it would be db.session.get, pass in the customer and then the ID of the customer you want. That gives us John Doe by itself. And then we can also do db.session.scalars. If we know we're getting 1, we pass in the statement here and do 1 here. So there are multiple ways of doing this. I recommend the first one, db.session.scalars, but they all work for different situations. So I'll use them when they're appropriate, but just so you know. So now what I want to show you is editing an existing record. So right now, let me grab the John Doe record. So I can do John Doe equals db.session and then .get, let's say, and I'll use customer and ID 1. So now this is the John Doe object. And if I do like John Doe.address, we see the address that's in the database. So 123 Fake Street. So if I want to update this, all I have to do is John Doe.address equals, and then I can put in a new address. So I can say 456 Fake Road, and then do db.session.commit, and then SQLAlchemy will save this in the database. So if I were to look inside of SQLite again, we would see that the address is 456 Fake Road instead of 123 Fake Street. So now let's look into deleting, right? So I've been able to create stuff and update it. So what happens when you want to delete? So let me go ahead and import product, because I'll demonstrate with product. So I imported product, and I'll create a new product. So we'll say product equals product. The name will be, I don't know, widget, and then the price will be 4,000. Okay. And then I can add it to the database. So db.session.add product, and then I can commit it. Okay. So that should have added it. And now let me open up a new terminal to go inside of the database here. So instance, db-lite, and then I'll just select star from product. Okay, so we see phone and computer are still there, but we also have widget. So let's go back to this one. And if we want to delete that one, we can first query for it. So I'll query using widget as the object that I will end up in. And then db.session get, and let's do product. And then the ID on that was 3, right? So if I go back here, yeah, the ID for widget is 3. So if I do widget here, like widget.name, we see widget. And if I want to remove it, I can do db.session.delete, and then I can pass in the object, so widget, just like that. And then do db.session.commit at the end. And then if I go back over here and run the same query, we see that the widget is now gone because I deleted it from the database. So it's pretty simple to remove stuff, as you can see. It's just as simple as creating and updating things. So what I want to do now is I want to bring in some fake data for this. So when I show you how more complicated queries work, there's like actual data to see. So what I'll do is I'll add a library called Faker. So UV add, and then Faker is the name. And then at the top of the file, I can just do from Faker import Faker. And then I have a bunch of code to add data to the database. So let me go ahead and copy it from my other screen. And then I'll just paste it at the bottom. And I'll quickly explain what's going on here. So we have this add customers. So this will just add 100 fake customers to the database. Add orders will take all the customers and then choose a random customer for each of 1,000 orders that it's going to create. It's going to choose between some possible coupon codes or none. It's going to decide if it's going to have a delivered date and a ship date, and then it's going to create it. For products, it's just going to come up with a name. The name of the product will be based off of a color for each product. And then we're going to associate orders with products. So this is the function for that. And then finally, we have this create random data that is going to actually call everything. So I think I need to import something at the top. I think just random, right? Because I'm using random here. So let me go ahead and import random at the top. And also for Faker, I need to instantiate a fake object. So here, so let me just do that above add customers. So we'll do fake equals Faker, just like that. So I believe that is enough to generate the fake data. So let me go ahead and go back to the shell. So UV run Flask shell. And then in here, I'll import the function to create everything. So create random data. So from app import create random data, and I'll go ahead and run it. So create random data, run it, So we have an error here. That's because I'm missing an import from SQL Alchemy. So SQL Alchemy, I need to have select here. So let me go ahead and restart and just run the same thing again. So from app import create random data, and then creates random data down here. And now it's taking longer and it looks like it created the data. So let's go back over here to the database. Let's select star from product again. And we see I have more products. And like I said, they're basically colors. So light blue, silver, they have random prices here. And then I can select star from customer. I should have a bunch of customers in here. So these are fake customers generated by Faker. So like Alexander Carlson, for example. And yeah, there are actually 200 customers. I thought there'd be 100. Oh, it's because I ran the function twice. That's fine. So select star from not order, but customer underscore order. And we see I have 1,001 orders in the database. 1,000 were added by my process for generating fake data, and the first one was added by me. And of course, we have the customer order product table that has the relationship between the orders and the products. So all the data is here that I want. This is randomly generated, so I don't know what it's going to end up as, but this makes writing queries a little bit easier. So instead of writing the queries in the Flask shell, I'm going to create functions in my app.py to run the queries, and then I'll just call the function in the shell. So let me go down here and I'll create a function. Let's say get orders by. So this function will get all the orders by a particular customer ID. So for the parameter, I'll have customer ID and I'll default it to customer ID 1, just in case I forget. And I'll just print something here so I know what function I'm running. So get orders by customer. And now we can write the query. So I'm going to start off by writing the statement. So I like to always start with a statement. And then what I want to do is I want to select, and I want to select from customer order, right? And then what I want to do is I want to say where customer order, okay, dot customer ID equals whatever the customer ID is that I passed in, right? So I want to get all the orders for a particular customer. And because the customer order table has a customer ID on it, I can just put that in the where directly. So customer ID equals whatever is passed in. And then I can execute the query. So I'll call this customer orders equals, and then db.session.scalars, and then pass in the statement, and then just do .all at the end. And what I want to do is I just want to print out the results. So I'll say for order in customer orders, this variable that I just created, I want to print out quite a few things. I want to print out the order ID. I want to print out the order date. I want to print out the ship date. Ship date, I think the next is delivered date. So I want to print that out if it's there. And then I think the coupon code is the last thing. Yes. So order.coupon code. So those are the things that I want to print out. And also what I can do is I can print out the customer name. So I can do order dot and then customer because I have this relationship on order. So let me go back to the customer order model. So because I have this customer here, I'll have the ability to do dot first name here. Okay. So let me go ahead and restart the shell and then import this. So I forgot something here. I forgot a comma. So let me run this and say from app import get orders by. That's the function I just created. And I'll call get orders by with no additional information. It will just default to 1. And we see John is the first name. So that's the name of the customer on that order. And then we see order ID 1. That's the one I created. But the rest of them are randomly generated. And then I can see all the information here. So they all have ship dates and they all have delivered dates. Some have coupons and others don't. Actually, they all have ship dates, but not all have delivered dates. Okay, so that's what I'm looking at here. These with none here, those are the ones without a delivered date. So they are shipped, but they're not delivered. Okay, so let me run this again, but instead of customer ID 1, I'll pick a random number. Let's say customer ID 83. So I'll run this. This customer's name is David, and then David has 5 orders. And then as we can see, we see all the orders here. So that was a pretty basic query. Let's write another one. Let's do get pending orders. So we'll call this get pending orders. It doesn't need any parameters. We're not going to pass anything to it, and we'll just print pending orders. And the idea behind a pending order is any order that doesn't have a ship date, that's going to be pending. And then once you ship it, it's no longer pending. The state will be like shipped or whatever. So we're going to select, and we're going to select from customer order, and then do a .where. And what we want to do is we want to look where the ship date is none. So we do customer order dot ship date, and then dot is underscore, and then pass in none. So this approach is just because is a reserved word in Python. So the creators of SQL Alchemy want this is to be very different than the built-in is. So that's why it's is underscore. And then we can just pass in none for null here. And then I can run the query. So we'll do pending orders equals, and then db.session.scalars, and then pass in the statements, and then just do .all at the end. And then for each order and pending orders, I'm going to print out some information. I'll print out the order ID, and I'll print out the order date. So order.order date. Okay, so let's see if we have any pending orders in the database. So I'll exit this, restart it so I can import this new function. So from app, import get pending orders, and I'll run it. So get pending orders here. And now we see I have quite a few orders that haven't been shipped yet. So these are the order IDs. So the first one was number 1. That's the one I created. So that one definitely didn't have a shipped date on it. But these other records also don't have ship dates on it. So this represents all the pending orders in my system. So if you wanted to know that, then you could do that. So now let's think of another simple query that we can do. Let's figure out how many customers we have in the database. So I can do how many customers, and I'll print how many customers here, and I'll write the statement. So for the statement, it's going to be a select, and this is going to be different. So I want to know the number of rows that gets returned by the query. So I could run a regular query and just get the length of this, but that would be inefficient because I have to do the whole query first, get all the data only to just look at the length. To get around that, what I can do is I can use a function. So if you're familiar with writing SQL by itself, you know there are functions in the database, and count is one of those functions. So from SQL Alchemy, I'll import funct. That's short for function. And I'll go back down here where we have how many customers. And I can say funct.count. So I want to call the count function. So inside of the select, I'm calling count. But notice that we haven't passed in the class yet. And to do that in SQL Alchemy, I do select underscore from, and then I pass in the class. So this is equivalent of writing select star from customer. It's a little weird how it's done, but this is the approach, and I wanted to show you. So here I can get the count, and I know the count's going to be just one number. So instead of using scalars, I'll use the singular scalar. So db.session scalar, and then pass in the statement. And then I can just print out the count. Okay. So let me go ahead and restart. And from app, import how many customers. And I'll just call this function. So how many customers? And we see I have 201 customers. All right, so now I'll show you one last query. Let's do a query to determine how much revenue we've made in the last number of days. So I'll create a function here, and I'll call this revenue in last X days. And then I'll default it to, let's say X days will be 30 days, right? So print revenue in last X days. And then I'll start by writing the statement, right? So first I start off with select, and then I have to think, so I don't want individual column data because I want some kind of calculated value, right? The revenue for the last 30 days is the sum of all of the prices for the products that were ordered over the last 30 days. So it's more of a complicated query to write, but if we think that the end value that we want is one number, one sum, then we can start in the select with that. So it's going to be function.sum. So once again, sum is a function in a database. And I want to sum across the price column in product. So do product.price. All right, so then I want to select from product in the same way because I'm using a function inside the select. So I can do .select from product. Okay, so if I just stop here, what it's going to do is it's going to sum the prices of all the products I have in the database, but that's not really interesting to me. What I want to know is the revenue that I've achieved in the last X days. So I need to bring in other tables to figure out this information. So I can use joins for that. So first I want to join the customer order product table. So where is that? I want to join this table, customer order product. So I can just copy the object and paste it here into join, right? But this table still doesn't give me enough information. So now I want to join the customer order table, customer order, and I just have to go through the customer order product table to get to customer order. So that's why I joined that first. And let me put this on a new line because I think this is going to get pretty long. So let's put slashes there and there. Okay, actually I want it here before the dot. Okay, so dot join customer order, right? So now I have all the tables I need to get the information, but I still need to filter it by something. So I'll do slash and then I'll put a where here. And I want to check customer order and I want the orders that happen in the last X days. So I can do customer order.order date is greater than, and then I want to do whatever the date time is now. So I'll just use datetime.now. I could also use UTC now or, at the time zone in there, but just to keep it simple, I'll do .now. And then I want to subtract a time delta of 30 days. So days equals X days, and that should be it. So let me make sure I have time, date time, and time delta. So from date time, I need time delta here. I believe that's in date time. We'll see in a second. But this is the whole query that I want. So the idea is I want to sum all the products that occur in orders that have happened in the last 30 days, right? So now I can have this revenue variable and do db.session.scalar, pass in statements, and then I can just print out the revenue at the end, assuming there are no issues here. So let me go ahead and restart. I'll do from app import revenue in last X days, and I'll run it. So revenue in last X days, we'll pass in, well, 30 is the default, so I'll just pass in nothing. And it says I made $55,000 in the last 30 days. So if I go with 10 days instead of 30, we'll get a smaller number, presumably, right? So 20,000. If I do like the last 5 days, I should have a smaller number, and that's 8,000, right? If I go longer, I get 90,000, right? So this is giving me the amount of money that I made in the time since in the last whatever those number days is by just running this query, because the most important part here is the customer order date is greater than whatever number I pass in. So that gives me all orders that match that, which are all orders that are in the last, let's say 50 days as the example. And then it's summing the product prices across all of those because it has the customer order product table. And then that gives me the revenue here that I'm printing out. So as you can see, if you're familiar with the old version of SQL Alchemy, things are obviously different, but it's also along the same lines. So I don't think it's that big of a transition to go from the old version of SQL Alchemy to the new one. And as you can see in Flask, it's pretty easy to use. There are some minor differences, so it's not going to be as convenient as it was before, but it's still overall a pretty convenient library to use in Flask. So you've seen how to work with SQL Alchemy in Flask. If you're interested in learning about common mistakes that you could be making in SQL Alchemy, check out this video here to learn more about those mistakes.